Tennis is back in Paris with the French Open at Roland Garros. My name is Yann, and in this video I'll show you how I'm using machine learning in order to predict the winner of this tournament. This year's final is opposing last year's champion, Carlos Alcaraz, to the #1 playing tennis player in the world, Yannick Sinner. The workflow that I'm going to follow is going to be in several steps. I'm going to use some data that I'll be collecting for 2024 matches and using a rating system called ELO. I'll consider clay-only games and ratings for each players because Roland Garros, as some of you know, is playing not on grass but on clay. And in each match, I'll be recording the rating difference just before the first serve. Features are going to be only two for the first pass at the problem: the ELO difference and the surface ELO difference. This is keeping the experiment laser focused on rating quality. The models that I'm going to be considering are decision trees, random forest, gradient boosting, and even a tiny neural network, a multi-layer perceptron. The scores, as you'll see, it's going to be yielding out 25% of the 2024 games as a testing set, stratified, so that we can test across the year. And all four settle around 58% of accuracy for the first round of of all of those training. And this is just showing you how far you can go with just ELO. So then what we'll do is, in order to predict the champion of Roland Garros, we'll simply simulate taking the 32 best clay players as of 1st of January 2025, and we'll estimate their win probability on a head-to-head with the random forest, averaging those and raising all of this to the 7th power to approximate the 7 wins in a slam. So this is the methodology. Let's start with a dataset. For this, I'm going to be asking ChatGPT, okay, can you find me a dataset to help predict who will win at the Roland Garros tournament this year? So for this, I'm going to be pointed to this source online of ATP, the Association of Tennis Players. It's gathering a whole bunch of information, and hopefully someone already did the hard work of collecting all of this data and scraping it all the way back to 1968, as you can see. For the first path at this problem, I'm simply going to be using the 2024 data, but it's actually good to know that there is a lot of data available online. So let's jump into some code. I'm going to simply be importing it into MATLAB and start some of the analysis. So here is a notebook that you'll find on GitHub that goes through several steps. Let me start by simply importing the data. So I'm going to select only a few columns here: the name of the tournaments, the surface, the winner, the loser, and the ranks. So those ranks are given by the ATP that will be calculating our own rank later on. Let's do some exploration of the dataset simply by looking at the number of wins for each of the players. So what we could do is here, as you can see, if I simply look at grouping the counts by winner names, I'm getting this table, and I can simply sort it out by looking at here the largest to smallest, which is going to give me Yannick Sinner as #1. Carlos Alcaraz is #3 only in this count, in number of wins in 2024. I can update the code, and this is essentially what you'll find in the GitHub repo. So this already sorted table. Now I can also look at a pivot table by surface. So let me do that, and here I've already also sorted it by descending order to see who's the best player on clay in 2024. As you can see, Alcaraz is #9, and we need to scroll down a little further to find at #25 Yannick Sinner. So you may remember from last year, that Carlos is pretty good on clay. Now let's drill down into one particular head-to-head. Yannick Sinner versus Carlos Alcaraz in 2024. And as you can see, well, Carlos won all the 3 encounters that they had in 2024, which give a pretty good, entertainment for tomorrow. So now now that we've done some exploration, let's look at how we could build features in order to analyze the performance of both players. I'm going to play a quick video that is going to show you here the rating as it's evolving in 2024. And as you can see, Yannick and Carlos are on the top, with, well, Carlos dropping just a little bit at the end of the year. So this animation over here is essentially based on this metric called ELO rating. ELO is a method for calculating the relative skills of players playing in head-to-head in competitions, like in chess. And initially this has been applied to chess player, but this can also be applied to other sports like tennis. You can find more online about the ELO rating system. So what it does is essentially start with the default rating of 1500, and every time that there is a win, it's increasing your rating, and if there's a loss, it's decreasing it. And beating a highly rated player earns more points than beating a lower rated one. So this is the general idea, and here you have a formula that gives you the expected score that is computed over here and updated. The rating is performed like this, with players A rating, player B rating, and the actual score. And here in tennis, this factor K, you'll see in the code, is commonly used as the 32. So here is a quick example of the algorithm that we'll be using. We're going to sort the dataset by date. We're going to initialize the rating at 1500 for every player at the 1st of January 2024. And for each row, each game, we'll be getting the rating for winner name and loser name, computing the expected score and updating both ratings based on the match outcome. So here is like an example of 2 rows, and giving you like for last season of Roland Garros, the winner, in this case Djokovic was winning against Alcaraz, and Sinner was winning against Casper Ruud. So let's go back to the code real quick, and we'll be computing the dataset ELO. So here we're going through all of the 6,000 something rows of the table, and we are essentially computing this metric. Okay. So this is it for ELO. Now let's use a set of models in order to predict who will be the winner at Roland Garros. And for this, I can ask my friend ChatGPT to recommend a bunch of algorithms that I could be using. I've trained a bunch in Python with scikit-learn, but I'm also using the, here as you can see, the regression learner in the classification learner, sorry, an app in MATLAB in order to do that. So I'm going to simply prepare the data. Here, this is the data set that I've just computed with ELO and the surface ELO. And let me just click again, and creating a partition, just stratifying automatically 25% of the data as a testing data set. So let's open the classification learner, which you can also find here in new apps. But I'm simply entering it in the command, and we're going to start a session. So we'll create a new session. We're going to be selecting here the training set. Let's see, from a whole bunch of inputs in my workspace. And the response is also selected from the workspace is Y-train. So you have a table here and a categorical value, and that's about it. So there's going to be some cross-validation during the training, and testing, we don't need to set data aside because we've already created a partition during the training. So this is the two, well, the Elo diff and the surface Elo diff. What we'll do is we can just use a fine tree here and simply train it, but we'll also use other models. So let's just see what the default model is giving us. It's about 50, almost 58%. And you can see here the confusion matrix to see what has been correctly classified here in the diagonal and what has been misclassified in the opposite of diagonal. And here you can see some of the misclassified cross, and you could drill down and look at what's happening over there. You can also just select a whole bunch of models, like all quick to train, and see if you can get a better result, better accuracy with some of the models. So let's just train all of those models. They are quick to train using MATLAB Online, and should be quick, fairly fast. So let's see if we can do better than 58%. So I'm thinking that maybe the KNN, yeah, this one, the course K nearest neighbor is doing better. And actually here, this is the logistic regression is not doing too bad. And you can continue like this. Let's see if we can do a gradient boosting method. I know that in XGBoost in Python, it was performing quite well. So we can also look at this one. Let's just use the default one and train it. And those methods are typically very quick to train, as you can see, and also quite performant, 59%, not too bad. You also have the ability here to use a neural network. I'm going to use the medium one. Let's see how it performs. Just simply one fully connected layer. Could go back to see what I've specified in Python, but to replicate the results, let's just see if this one is, yeah, it's pretty quick to train and is 59% as well. So we have something between 58 and 60% of accuracy. And we could continue and export the model for further prediction in our workspace. Okay, so now let's look at the different models that has been suggested. So decision trees one, we have a decision tree over here. I've actually replicated all of the code programmatically in MATLAB, as you'll see here in the notebook. So if I remove this app, I can also look at here the decision tree that I've been using. Let's see how it performs. Control Enter, 59%. And it's giving me this view, which is kind of nice because it's clearly explaining to you the direction that every decision is taking, essentially, which is a reason for the name of decision tree. You have here a random forest, which is essentially scaling this approach to here 200 trees, and you simply shuffle the distribution of the data sets in order to randomly train those trees. And as you can see, it's actually giving us a fairly good accuracy of 62%. So actually much better. And now let's look at the gradient boosting method. So the Logit Boost, I was using the ADA Boost in the learning app, but this one is a different one. So let's see, 62% as well. So yeah, typically the random forest and the gradient boosting approach have been both very performant. Okay, so that is it, and you'll be able to replay all of this from my GitHub repo. So random forest, there's actually, if you want to look it up online, there's an implementation of this algorithm that is explained and implemented in pure MATLAB by Mr. Karpati, Andrzej Karpati. I forked his repo. He's a legend in AI. So I was quite happy to see that he had been using MATLAB a while ago. And I've simply changed the color map in Parallel because I find it to look better. Okay, so let's go back and see some of the conclusions. So gradient boosting and neural network, those are the different ones that we've used. And here, those are some of the accuracies that I've been able to secure. Those results were in Python, but as you can see, the results in MATLAB are approximately the same, sometimes a little better. The accuracy is ranging, it's around 58%, right? 58 to sometimes 60%. We've been able, as you can see, with MATLAB to get all the way to 62% with gradient boosting, which was actually quite good. So now that we see that the accuracy is it's barely more than a coin toss, if you think of it, like 50%, it's just tossing a coin, and you'll see, head is this guy wins, and tail is this guy wins. So the model accuracy is quite poor. So I'm going to ask ChatGPT select other predictors from the dataset and tell me why they seem to be relevant to the analysis. And this part is quite interesting. So those are new predictors, like the ATP rank difference. So we've seen that it corrects some of the tricks that Elo sometimes under or overreact to. So we have two different ranking systems, which is actually quite good. They don't always correlate clearly, so we can see some patterns there. The rank of point difference, so the winner rank points versus the loser rank points, and this gives us a finer granularity than just the integer rank. The age difference, we can also see sometimes that younger player recover faster between matches. This would have been the case if we would have seen Djokovic against Alcaraz in the final, but well, Djokovic lost. So I guess we're going to see two young players, Sinner and Alcaraz. They just have 1 year of difference. And yeah, sometimes the stars they decline on long clay rallies. The difference in terms of the height proxies for serve power and reach, it can translate into 3 points and breakpoint defense. Same end in this case is not going to apply because they are both right-handed players. And why do they work together with Elo? Well, you can see head-to-head momentum and surface specialization, but here rank points bring the overall season form, and Elo is slower to shift if a player skips a few events. Age, so some biomechanical traits, I would say, that the rating system is ignoring, so that's also quite complementary. And same end is something that is sometimes a quirk in the matchup. So those extra variables are not strongly collinear with Elo. So the ensemble models can pick up independent signal rather than the redundant noise, which is kind of nice. So this is the first level. Now let's go to the next level of feature and let's add a few more even, because I've seen actually some progress with those metrics, but I'm going to continue adding more and see what can continue improving the accuracy of the model. So I'm not going to give you all of the detail of each of the iteration and the scores, but just like the conclusion of where I landed with all of those analyses. So let's look at those next 4 metrics predictors. Short-term form, it's capturing the odd streaks or slumps that Elo and ATP they smooth out. The serve firepower, we can look at the average aces during the last 10, and this gives you 3 points on serve that matter even more on quick finishes. So best of 5 still rewards big serves. Fatigue and recovery, long marathon can drain players from the next round. And rest, finally, like you look at number of days between matches, they rested players perform better, and clay events even give only 1 off day. So you've seen between the days at Roland Garros only 1 day of rest. So some feature engineering, the performance impact is actually quite significant. as you can see, with I'm just looking here at the random forest, that was 58%. We've gone all the way to almost 75%, with a pretty good average under the curve metric. And it's actually a very huge lift for just a single season data set. So I'm still just looking at 2024 only. So those 9 additional features, they give me a lot more predictive power, which is quite interesting. And this is both true for the random forest, but also for the gradient boosting method. Now let's extend Elo and all of those features across 5 seasons. So I've only looked at 2024 just for the sake of just simplicity, but actually I can go all the way back to a long time ago. I'm only going to go and look at 5 seasons from 2020 to 2024, and it's giving me just a few additional percentage points, sorry, going from 75 to almost 76 in accuracy, and also for the area under the curve, going to 84%. So in both metrics, that's modest, but that's expected because the Elo is converging quickly. So most of the big gains came from the enriched feature that we've added. So the extra season is polishing some of the edge. It's a better initial rating for young stars, because you remember that the Elo system was starting defaulting at 1500. It's going to give a cleaner rolling window, almost no empty history for back, and a more balanced training set with a lot of varied surfaces and players form. So it's better data. So what we do is here, in terms of step, we ingest all of the 100,000 lines of 5 CSVs, same K factor. We're going to look at 10 match windows. We have plenty of data now for newcomers. And we can also do something that was quite nice. The evaluation splits is looking at training from 2020 to 2023 and using the whole season of 2024, which is a true out of sample and time ordered validation or testing set. So this is quite nice. And the result is Jannik Sinner is predicted to win with 63% of probability. This is the edge that is given to us by the model. Let's look at the feature, the importance for the gradient boosting model. So we can see that the ATP ranking difference is fairly significant because you have the number 1 versus the number 2. So this is obviously playing a role. Also, the overall Elo difference is playing a role, again, because Sinner has a kind of an edge and advantage over Alcaraz in terms of this Elo rating. Now, when we look at the clay Elo, it's actually Alcaraz that should come on top. And you may recall from last year, well, you know, he's really good on clay. The age difference is not very significant because they're almost the same age. They're almost the same. No, Sinner is a slightly taller guy, same-ended. So here are some details. And yeah, well, this is about it. We've seen that all of the 4 models that we've trained are agreeing with this percentage of chance, roughly 60 to 65% of chance for Sinner to win tomorrow at Roland Garros. So we'll be looking to see. You know, it's quite close because Alcaraz is very good on clay. He's the best in the world since Nadal has been peaking on this tournament and on this surface. So we'll see. Let's see what tomorrow gives us.